As more objects are becoming embedded with sensors and gaining the ability to communicate, the resulting information networks promise to create new business models, improve business processes, and reduce costs and risk, presenting enormous opportunities for us and challenges. Here today is Bob Conrad to present his thoughts on the Internet of Things. Bob is a Senior Vice President and General Manager of Automotive's MCU for Freescale Semiconductor. He has more than 28 years' experience in the semiconductor industry, spanning microcontrollers, digital signal processors, analogs, discrete products in automotive, communications, storage, computing, and handset markets. Bob joined Freescale from Fairchild Semiconductor, where he ran the analog and low voltage discrete business, along with technology development and strategy. Prior to that, he managed the analog device DSP group and was the automotive microcontroller manager at Texas Instruments. He was director of Mindspeed Technologies, and from 2010 until the sale of the company in 2013. He holds a bachelor's science degrees and electrical and computer engineering from the University of Cincinnati, and is on the board of Mindspeed. Please welcome Bob Conrad.
Thanks, Jim. Thanks, Jim. So yes, I'm a chip guy over 30 years. Freescale, if you don't know, is about a $5 billion semiconductor company. We have 5 different business units, and 3 of them are actually very related to the Internet of Things. First, and actually the most significant, is our general purpose microcontroller group, which you may be surprised to find their products are in everything from wearable fitness devices to GoPros and consumer devices and all those types of things. Another, because there's an infrastructure that's needed for the IoT world, is our digital networking group. This group also works on the infrastructure, whether it be wired communication or wireless. Let's see if we get slides here. Okay. And then I'm the automotive chip guy. You may think it's a little odd for a chip guy working on cars to be talking about the Internet of Things, but I will. I wanted to talk to you today about the Internet of Things with a few extra examples from the automotive industry, because it may not be things that are quite as apparent as some of the other things that you see. The Internet of Things is not really a revolutionary idea, at least from my perspective. To me, it's simply the progression of mankind's march to be more connected. From the written word to the printed word, to the telegraph, to the telephone, I still remember as a young engineer being really fascinated by the fact that IBM could call into the mainframes in our company and diagnose what was going on. That was the Internet of Things in those days, even though it was before the Internet. After that, then we had the Internet and our big experience in our lifetime about being connected through the Internet, through dial-up modems. Again, I can still remember when it was really the big deal to move from 96K, 9600K to 56K modems, and that was what we thought about as being connected. Today, that seems like a real antique. Then we moved to the mobile phones, and then to wireless things today, which are really making up the things that are focused on the Internet of Things. This is really the evolution of decades of embedded processor developments that improve performance, reduce power, reduce space, and are now adding intelligence to things near and far all over our life. Here you see a picture of old applications. Many of these things have been around for decades. They've improved our lives. Shoes, they've been around for a long time. Light bulbs, what would life be like without light bulbs? But these have really been mostly in mature, conventional markets. And 10 years ago, if you were in these businesses, you probably would have thought about they were mature, cost was everything, scale was everything, maybe channel and branding was everything. But a lot has changed over the last 10 years. Today, these old applications are really experiencing embedded intelligence. Embedded processors and sensors make these smaller, more economical, and they're very energy efficient. Otherwise, wearing them, doing them from a battery power perspective, really would not be possible. All of these embedded processor and sensor products in these types of products have brought on a new wave of innovation. These smart devices have new features, watches that can keep track of how much you should be exercising, whether you have or not. For example, smart light bulbs, thermostats that you can talk to through the internet, control integrated HVAC systems around your house are all examples of these. They bring increased efficiency to your way of life, enhanced quality of life, and they're also capable of collecting data on where you use them, how you use them, and perhaps what you use them for. From the automotive point of view, embedded processors and sensors have been in cars for decades. If you go back to the 70s, early adoption was really driven by fuel efficiency. And then later, things like airbags and anti-skid braking were examples of embedded processors and systems in cars. Connectivity in cars for a long time, state-of-the-art really looked like OnStar from GM, which was really also a safety-driven application. If you got in a crash, the car could notify somebody, or you could push a button and talk to somebody. Now, newer cars have much greater connectivity. You've got multiple USB ports, whether that's to connect your device or charge your device. You've got Bluetooth so that you can seamlessly walk into or sit in your car and have your phone connect. And in a hands-free manner, you can control the car. And you also not only use that for voice, but also you have often through your cell phone or other means connection to the internet. So data is flowing whether or not you know it or like it. So with this, there's a dramatic expansion of networking infrastructure. Devices are connected to each other with technologies like Zigbee, mesh networks. I found those recently as I put some thermostats into my house, or through the internet through Wi-Fi, which has become ubiquitous absolutely everywhere. And this change is really happening at a dramatic pace. Again, just 5 years ago, you wouldn't have really thought about your watch, your tablet, or many things in your car actually being connected. Today, examples of benefits of being connected in the car market are very apparent in things like fleet applications, where shared data is really used to drive efficiency. You can see that in delivery type of applications, whereby the company really understanding where their drivers are, what needs to happen next, you can do fuel efficiency through optimizing routes. Or another example, service to the general consumer. I don't know about where you live, but in the United States, it's been a decades-old joke about the cable company who would tell you that they're going to come Tuesday morning and they might show up on Thursday. But today, in the United States, we start to see ads about cable companies actually competing on service, where they will schedule their technician to be at your house within an hour, and they actually do that. And they don't do that by quadrupling the capacity so that they make sure they have somebody available. They do that through efficiency of connected devices with knowing what those technicians are doing, where they're at, and what may be needed next. It's an example of how connections are bringing advantages and bringing new services. So all these smart devices and the ability to connect all these are really driving an explosion in connected devices. Over the next several years, 2020 really is not all that far away. It's estimated that connected devices will exceed the global population of the Earth by a factor of 6. Absolutely phenomenal. This Internet of Things is really being enabled by a shift from proprietary infrastructures and dramatic cost reductions to really have the focus of the technology being moving away from just how you connect, which many proprietary architectures and technologies did a number of years ago, to really what you can do with the device, how efficiently that device may run and where you may be able to take it. So excluding PC and smartphones, which are probably two of the most visible connected things to the internet, IDC forecasts the connected things will soon exceed 28 billion devices. That is surely a boatload of things out there. So for the ICT community, what does it mean? Some of them are obvious and some are maybe less so, but it really represents a massive opportunity and challenge. A lot of this is really being brought on by big data. The ability to analyze and act on data in a scale that hasn't really been seen before in these types of applications. Today, more data is actually being generated by things than people. Again, that was really not true just several years ago. If you think back over the last decade, tremendous value has been created by the use of big data, but mostly related to people. The way I think about that is, what did Google and Facebook really look like 10 years ago? To me, the tremendous wealth that's been created there and value to many constituencies is really the result of their ability to understand big data and help others, whether it be customers or themselves, target goods and services to people based on what it is they're doing, what they're looking for, and in some ways they know what you want to look for before you do. But what about big data from things? I think that's the new frontier. How will value be realized from big data generated by things? Industrial applications are actually maybe not that hard to imagine. Adopters of machine, the industrial segment has been an adopter of machine-to-machine communication for quite some time. That example I gave on whether it was IBM mainframes decades ago, or another example from my early engineering days was we had big automatic test equipment systems, and many of these we could also communicate with remotely, again through phone lines. It wasn't very sophisticated, but even in those days it impacted our productivity quite a bit. And usually these industrial applications are really driven by efficiencies. These days, another recent experience I had on this was I recently opened a water bill and realized that I was being charged extra because I had not approved a smart meter to be used at my house. So now, if you're not smart, if you do not have connected devices, you have to pay for the inefficiency of that. On one hand, it's a bit irritating, but the other, it makes perfect sense. So I think industrial applications are fairly straightforward. But the general public, how you use big data and how you gain value from that by targeting sales of goods and services has really yet to happen. Again, it's happened around social media and search, but how do you do that when it comes to your personal information about what's running in your house? Are you awake or not? Is it time to send that coffee commercial to your display in your home because they can tell somebody just woke up? So I think in the case of the general public and people, the increasing challenges are really perhaps more around privacy and security, a topic which I know gets a lot of airtime and is never easy to solve, but is one that's primary to actually being able to realize value from big data on the Internet of Things. Some of these examples are, I think, becoming more and more prevalent in different parts of the world. Connected home has been a long-standing theory. 10, 20 years ago, you could buy home automation systems, but they were really quite clunky. They were quite outdated in just a matter of a year or two. I mean, today you can buy smart thermostats to control your HVAC system, smart cameras, smart locks, smart lights, televisions, all these types of things are available, and they're all accessible by applications on your smart device or your smartphone. Again, even 5 years ago, these things weren't very prevalent around the world. I grew up in small town Ohio. For those of you who don't know the United States, that's in the Midwest. It's not one of the two coasts. And when I grew up, being connected meant that you had one single landline, and for us it was one of those big black AT&T phones that hung on the wall, and it was actually a party line that you shared with your neighbor. We thought it was still pretty cool. You could actually talk to people. But now my house has all these things. We've got thermostats, lights, the pools, TVs, and other things that are all connected to the internet. And again, I can access them just about anywhere in the world. Sometimes I'm not sure that I want to or need to, but it's actually quite fascinating, and it brings a lot of peace of mind in certain situations. So being connected in the home has changed a lot over the last 20, 30 years as well. Well, let's look at cars a little bit more. What does being connected in the IoT mean in the car world? Today's cars are actually pretty aware of their surroundings, but they're not very connected. In this picture here, what these kind of zones before and after cars are really indicated to show is the radar example. In many new cars today, you can get a system adaptive cruise control that will maintain a distance from the vehicle in front of you, or emergency braking. These are long-range radar systems, usually with one sensor right in the front or perhaps one in the back if you're getting some of the other information, that's really used to detect an object, its distance, its rate of speed, and its vector. And these are really kind of assisted driving type applications. But what connected means inside the car is changing quite a bit, because while these cars are self-aware in certain ways, they really aren't connected to the external world. Automotive Electronics has grown tremendously. As I mentioned, we ship about 6 processors for every car built in the world every year. And many of these in these circles that are surrounding the inner circle here are in largely independent systems. Things like the engine controller for spark and fuel management, the transmission controller, the HVAC controller, the radar system, and sometimes vision systems, backup cameras, blind spot detection, anti-skid braking. It goes on and on. The worldwide average of processors for car is approximately 25, believe it or not. And a high-end car from Western Europe, a luxury car, that number can easily exceed 150 processors per car. And even a basic car in most parts of the world is really 5 or 6. So there are many, many processors already inside the car. Most of these historically have not been connected, or they've been connected in a minimal way, to where you can only check the status, maybe push a button, and you communicate to push a window up and down, or so on. But this is also changing quickly. Recently, we actually introduced some products that were related to bringing Ethernet into the car. And the application that's driving that is adding more and more cameras around the car. Cameras have found their way into the car initially for backup, which is a fairly simple application, fairly standalone, except that you have to get that information to some kind of a display to the driver. But stereo front-looking cameras are being used in some cases as part of active suspension. 4 cameras are being used to stitch a 360-degree picture of the car together. Sometimes today it's kind of just for gadget heads or people that find that to be really fascinating, or you might want to use that for parking, but in the future those are far different. But when you put that type of a video application in a car, the amount of data that you now need to move around the car, it really, really explodes. So in that sense, that's what's driving the adoption of Ethernet in the car, even though today it's largely for video applications. But I would think over the next several years, you'll see Ethernet connecting many, many more in the automotive version, the high reliability version of Ethernet. So connections within the car are starting to look more like what you see in an enterprise today. For safety applications, again, maybe OnStar was the previous example, but there are new developments in vehicle-to-vehicle, vehicle-to-infrastructure connectivity. In North America, the Intelligent Traffic Management System, the government has just put out regulations where cars will have to be able to talk to each other, mostly around trying to navigate collision avoidance in intersections, left-hand turns, and those types of things. But whether it's vehicle-to-vehicle communications or vehicle-to-infrastructure, these are all about bringing external context to the car for the purpose of safety. So what we're starting to see happen as time goes on here is these onboard systems are being connected, and a higher level of intelligence will emerge that sits above that integrates that entire picture, not only of what the car sees, but what the external world sees, either through the ITS system or through connections to the cloud. That can be both for safety applications as well, like vehicle-to-vehicle communications, or infotainment and context, like what pizza joint might be coming up. There's a gas station 2 miles ahead, or there might be a wreck around the corner. So connectivity, both inside the car and outside the car, are really changing quickly. These are also building blocks on the way to automated and autonomous driving. Today we generally have assisted driving, where the car, through sensors and systems, will give the driver additional information, but the driver is still generally making the decision on what should happen next. A couple examples that go beyond that, like emergency braking or adaptive cruise control, are there. But automated driving is the era of these systems in combination with external context being used to really have the car drive itself, but in limited situations. Perhaps a freeway situation where you stay in a lane, or it's a stop and go, or city driving, those types of things. Or even beyond that, autonomous driving. And I think it'll take a long time. There'll be many regulations and liability issues to be dealt with before autonomous driving really becomes a reality. But the other practical part of that is really generational and social norms. Some studies, being from North America, there are a lot of cars and everybody's very familiar with cars. But some of the early studies have shown that markets like China may be much more open to actually adopting autonomous driving, because the driving population is much younger. The use of technology in new ways is much more familiar. So instead of the West leading adoption of autonomous driving, perhaps it will be the East. So these are all steps that move along the progression from isolated safety systems to autonomous driving. And the car is really one big thing that's connected to the internet. So all these capabilities mean a lot of growth in connected cars. By 2018, approximately 1 in 5 cars will be self-aware. Self-aware meaning it knows what its perhaps maintenance schedule is, what it should need to be done, and it can communicate both to yourself as the owner perhaps the garage to schedule an appointment as well. The number of cars connecting to the internet will increase by at least sixfold over the next several years by 2020 to 150 million. That's still only a small proportion of the cars in the year. There are approximately 1 billion cars on the road around the world, and there are 85 going to 90 million cars sold per year. But the diffusion rate is quite high of connected cars. So all this internet connectivity, as I mentioned, will really bring greater context to the onboard systems, not only for kind of infotainment and entertainment applications, but also for safety. But this connected from 150 million cars to the cloud represents the big data opportunity for the ICT community. There will be a lot of information available about where that car went to, what the passengers really wanted to do, what they were looking for, what the activity was. And this really represents a big opportunity. Once again, some of the issues around security and privacy will have to be solved for that to happen. So while we tend to think of the Internet of Things through some of the more typical examples of wearable devices, the Internet of Things is a big deal to the automotive world as well. So moving to wearable technology, these are the things that you see many ads for and a lot of experimentation being done by consumer product companies around the world. Fitness bands, smart watches, smart glasses, action cameras. Those of you who have teenage kids, I'm sure they've probably asked you about a GoPro, which happens to have a Freescale processor in it. But my kids have one, and I had a lot of fun playing with one, although I'm not the daredevil that my 13 and 17-year-old are. So these applications can actually be not only quite useful, but they can be a lot of fun too. And again, 10 years ago, who would have thought you'd have a high-definition camera that you could wear, experience the things from your point of view, and play that back for friends and family or yourself when maybe 15 years later you can't actually make that jump off the waterfall that you did when you were a teenager. So it's a lot of fun. But this wearable technology market is really expected to grow tremendously over the next several years to around the $20 billion level in 2018. This is really opening the door for a lot of new business opportunities through capitalizing on new product and service ideas, in this case, maybe highlighted by the fitness and personal health services industry. So wearable technology is a whole other category of things that are being connected to the internet. So as I mentioned, one of the 5 business units in Freescale, again, about 3 out of 5 or 60% of our revenue is in some way connected to the Internet of Things, is networking. All of these connected devices, all of this data can go somewhere, needs to go somewhere, even if it's not harvested, just to be able to make it all connect and do what it's intended to do in the first way. So this is driving a rethinking of the network infrastructure. One of the dimensions that really, I think, will prove itself to be a solution is software-defined networking. Software-defined networking is easier to set up, it's easier to use, it's easier to provision, and it provides a much more cost-effective solution to networking challenges over the long term. But SDN is a new technology. It'll take some time to really deploy, but it does represent next generation. And we really expect that it will be implemented in phases over time in a hybrid fashion over a number of years as information and this new equipment is integrated with older equipment. So overall, over the next few years, the Internet of Things really promises to reshape many of the products that we're familiar with in a new way and change the way that we use them every day. They'll be smarter, they'll be more intuitive to use, they'll dramatically impact the way we live our lives. Manufacturers and retailers need to develop new business models for the connected consumer, and you see a lot of experimentation going on these days in new products. The ICT industry will need to match this pace of innovation, whether it's just getting all this technology to work so that our customers are happy with how it works, or capitalizing on the opportunities associated with big data and new services. We're really entering a new era of connectivity, and I can't wait to see what it brings to us next. Thank you very much.
finished about 2 minutes early, so
Oh,
I
sorry.
okay.
You told me don't run over.
Okay. Thank you very much.
Thanks.
Please stay here for a moment. We've got a little
Oh, great, thanks.
different.
Oh, thank you very much.
Bob Conrad, everybody. Thank you very much.
Thanks, Tim.